Hi, today I'm going to be presenting 2008 AMC 8 problem number 25. Margie's winning art design is shown. The smallest circle has radius 2 inches, with each successive circle's radius increasing by 2 inches. Which of the following is closest to the percent of the design that is black? So I redrew this diagram to be a bit bigger, and this radius is 2 inches because it says right here, the smallest circle has radius 2 inches. This is the smallest circle. Each successive circle's radius increasing by 2 inches means that every circle after the smaller circle, like this white one, the one after that, has a radius of 2 plus the previous one. So this one has a radius of 2. So this white circle would have a radius of 4. This black one would have a radius of 6. And the other right one will have a radius of 8, and so on. This last circle will have a radius of 12. And since it's a circle, that's good because that'll help us in many different ways, including finding area and stuff. This last circle has radius 12 because this is 2, this white one is 4, black one is 6, this other white one is 8, this second largest circle, this one, is 10, and the biggest one is 12. So the radius of the art design, which is the biggest one, is 12. The formula for area of a circle is pi r squared, because this whole thing is a circle. R is equal to the radius, which is 12. So we can put in the value of the radius to find that the area of the whole art design is pi times 12 squared, which is 144 pi. So now let's look at the area of this black strip over here, or black stripe thing. I don't know what it's called, so if you know what it's called, put it in the comment section below. This is equal to the area of the second largest circle minus the area of the third largest circle, because the second largest circle is this one, this black one, and the third largest circle is this white one. If we subtract those areas, we'll get the area of the middle one, which is the black part, the stripes part. These inner circles don't matter because since they're contained in this bigger circle, it wouldn't make a difference if they were there or not for this part only. For the rest, they would make a difference. This black stripe is the area of the second largest circle minus the area of the third largest circle. The radius of the second largest circle is 10 because this whole thing was 12. You subtract 2 to get the radius of this one, which is just 10. So the radius of the second largest circle is 10. We plug that into the circle formula to get the area of the second largest circle is pi times 10 squared, which is 100 pi. The radius of the third largest circle, this white one, is 8. Because if this was 10, we just subtract 2 to get 8 for this one, because each successive circle is 2 plus. If this is 8, then this bigger one would be 10. So the area of the third largest circle is pi times 8 squared, which is 64 pi. So now we can subtract to find the area of this black stripe thing, which is 100 minus 64 pi is 36 pi. So I'm just going to write that here on the next slide too, because we'll need this later. I also redrew this diagram for less confusion. The area of the second largest black stripe thing, that's this one, is equal to the area of the third smallest circle minus the area of the second smallest circle. This is the third smallest circle. This is the second smallest circle. To find the area between those circles, we subtract. So we get the radius of the third smallest circle is 6, because if this is 2, this white one is 4, and this black one is 6. And the area of the third smallest circle, if we plug it into the area formula, is pi times 6 squared, 36 pi. The radius of the second smallest circle is 4, because this is 2, and this white one should be 4. If we plug it into the circle formula, we get pi times 4 squared is 16 pi. Now we have the area, so the area of the second largest black stripe thing is 36 pi minus 16 pi, which is 20 pi. Now we have to look at this small circle, because that's also pretty much black. That is black. So if we add up all the black parts, it'll help us in finding the percent or the ratio, either way. So we have to find the area of this circle now. The radius of this circle is 2, it's just mentioned here. Plug it into the area formula, we get pi times 2 squared, which is 4 pi. To find the total of the black area, we add them up. Like earlier, we got 36 pi right here. This one was 20 pi and this one was 4 pi. To find the total black area, we add. So 36 pi plus 20 pi plus 4 pi equals 60 pi. So the area of all the black portion combined is 60 pi. The area of the full circle, we know that was 144 pi, the total area. So if we want to find the percentage that's black, the way we do that, first we divide, then we multiply by 100. That's the way to find the percentage. So let's divide. Let's divide 60 pi over 144 pi. The pi's cancel out, and we get 60 over 144, which can be simplified to 5 twelfths. Now we just got to multiply by 100. 5 twelfths times 100 is 500 by 12. And if we divide, we get it's 41 and 2/3, which is closest to option A. So the answer is